Hi, it's a favorite course Operation Research, yet with Dr. Peter in a CEO marketing team. We should go straight to a simple Q model, MM1. M, first M for the Poisson process of arrival, second M for the exponential process of service time, while we have just one server with the one signifying that some basic assumption, no backing up right then. This has to do with not leaving the queue before being served and do not leave while within the queue regularly. No priority among entries, all entries are treated equally. 3. Steady state behavior. The system has reached a steady state, meaning that its behavior is consistent over time, and the probabilities and metrics related to that queue are stable. Now we go to formulae for the MM1 to practical problems. Utilization factor, we've seen that utilization factor is given by a rho equal to the arrival rate by the service rate. And given the 6 simple example, the arrival rate of 5, service rate of 6, utilization factor will be simply derived as a 5 divided by 6, which gives you 0.8. That's about 80% of the time the system is busy, or let's say 83% of the time. The probability that exactly 0 units are in the system is about 20%, because that is just 1 minus the utilization factor. The probability that exactly n units are in the system, we have the P subscript n equals to when the system is being idle and when the system is being used raised to power of that number 5. And of course, that gives us a 0.07. The probability that n or more units are in the system, we have the utilization factor raised to the power of n, and that gives us about 40% that n or more units are in the system, 105 units, which is more probably likely than having exactly in units. Average or expected number of units in a queue that form from time to time, or we want to put it simply non-empty queue. We have that size to be determined by D equals to the service rate divided by the service rate minus the arrival rate, and that gives us a 5 from our example. Average number of entries in a system is given by the length L equal to the arrival rate divided by service rate minus the arrival rate. Okay. From our example, again, we have the length of the system to be 4. The average number of entries in a queue given by lambda square over mu minus lambda inside the parentheses multiplied by mu, and when you plug in all the values from our example, we have about three entries in the queue. Well, so average waiting time in the system given by W equal to 1 over the service rate minus the arrival rate, and that gives us a 1, which is good enough. So this is all we have for this section. Please, we employ you again to please do subscribe so you can see us in the next video. Bye for now.